All right, in this video, we're going to be doing some trig identities here, and using the sum and difference formulas, and play by the same rules that we did with our other trig identities that we did previously. And for this first one here, we're going to try and get this guy to look like this guy. Now, normally you'd split it down the middle, but I'm going to be doing lots of writing, so I'm going to, at the end of the day, just try and make it look like sine x, okay, the left-hand side. So we have cosine, so it looks like this is logically the best one to, the best formula to knock it out, where I have alpha and I have beta right here. So I'm going to go cosine of pi over 2 times cosine of, and then I have beta, which I'm going to just call x. All right, I have a minus sign here, so I know that this is going to be the opposite relation, which is going to give me a plus, okay? And then I have the sine of pi over 2 and the sine of x. Okay, now to show that these are going to fall apart kind of nicely here, is that we know that the cosine of pi over 2 is 0, okay? So I got 0 times the cosine of x, so this entire side is just basically, or I should say the entire left-hand side of the addition sign is going to go away. So that kind of cancels its way out. And we know that the sine of pi over 2, or the sine of 90 degrees, is 1, so I just have 1 times sine, which at the end of the day, I just have sine x. Okay, so that's kind of an easy one, and it kind of shows you the flavor of how those are going to interact with one another. This other one, though, seems like it's got some more work to do, so let's check it out. Okay, we got some alphas and betas in here, and we got some stuff in it. Again, I'm going to have kind of pinch for room here, and so I'm going to get this left-hand side, and I'm going to try and make it look like this using the properties above. So it looks like we're dealt cosine again, which isn't a bad thing. And so I'm going to write it looks like cosine alpha minus beta, which is just basically that guy rewritten out. So let's do that. So I'm going to write it out real quick. Okay, so there's the first step, expanding the numerator using the sum formula, or I should say the difference formula for cosine there. And then what I'm going to do is that I'm going to, since it is being divided by a single term on the bottom, okay, anything that is being multiplied together, I can use that to split each fraction into two different ones. So let's do that. Okay, and so now I have some interesting stuff going on here, because it looks like I need 1 and I need some tangents. Well, the 1 is easy because all of this is just everything divided by itself, so that's going to give me a 1 right there. So I know that I got that 1 taken care of. And fortunately, I have the definition of tangent as it relates to sine over cosine right here. So this is going to be tangent alpha, and this is going to be tangent beta, which takes care of those two. And so at the end of the day, I get 1 plus tangent alpha times tangent beta. Okay, and so looks like we did it. And so again, that kind of ties in sum and difference formulas. And look for the proof of the original ones a little bit later. It's pretty complicated, but it's very interesting. And so it looks like we are moving on to this business of the double angle formula. So I'll see you in the next video.